Hey everyone, Eric Yuzwa here, and in this episode we're going to be starting a static library for C++ and building our, I hesitate to use the word engine, our game framework, game library, game collection of objects that we are going to be starting to use and integrate in the projects that I'm looking forward to tackling. I will be using Visual Studio 2019 and the Community Edition, and that kind of leaves the door open for you to import it into your favorite 2019 or 2022 Community Edition editor. We're going to be taking advantage of SDL2 as well as, we'll just start right there. Okay, so my plan is we are going to look at starting up a static library that we can dump a lot of our shared common code into, and then anything that's kind of specific to a game or another type of project that we're gonna put together. But in this instance, it's gonna be mostly games. We'll just keep those separated within each of their own respective projects, and this way we can sort of set up a common testbed structure, engine structure, framework, library, objects, group of stuff that we can use going forward in all of our projects. And that really cuts down on the time it takes to get things going and looking nice to prototype with. My plan is to just focus on 2D. So this will be a 2D project only, and I'm not going to separate out the graphics engine into DirectX, Vulkan, or OpenGL. I'm just going to stick to the straight SDL2 renderer, let it handle everything it needs to, and just try and keep things as simple and basic as possible. And hopefully this gives you or anyone coming across this project, it gives you a way of coming up with an easy to drop in game solutions and getting started on whatever it is you want to build or prototype. Whatever you had in your mind, you can get started on hopefully a lot sooner rather than later. All right, so with all that preamble out of the way, as you can see, I'm in Visual Studio 2019. We're in the Create New Project screen, and we are going to go ahead and create a static library. Now, if you haven't used libraries before in C++, they're basically a collection of anything you want to store. So like a grab bag of variables, objects, classes, structs, enums, anything you want to throw into them, and then they become common code that you can statically link into any other project you develop. And statically linking, of course, means that your project at compile time includes everything that's in the library, and so it kind of the compiler, between the compiler and the linker, they figure out a smart way, as smart as possible at least, to structure and organize any memory or address spaces that your binary will need. With that out of the way, let's get started. Okay, so I'm highlighting Windows Desktop Wizard here, and I'm going to hit Next. And my project name is going to be called Moongate. So I'm going to make sure that I'll put all this code up on GitHub. It'll be available for you to download and use to your heart's content. So we are going to be, so the solution name will be called Moongate, and the project name will be I'll just call it Moongate Static Lib. Okay, hit Next. And then in the application type, I'm just going to select static library and empty project, and I'm going to hit OK. So if I right click on Moongate Static Lib here, I'll be able to open the folder in Windows Explorer, and I'm just going to make two folders, include and source. And of course, with the intent of our basic include file going in the includes and the source going in the source. Shocking, I know. Okay. So let's say in the include folder, I'm going to create a new file, and just our moongate.h. Cool. Okay, so in our header files here, I'm going to add an existing item, moongate.h, and let's just flesh it out with one function here. So if in def moongate.h, let's define moongate.h and if, okay, and we want to include our STL libraries, STL.h, and I think we'll just leave it as, we'll just leave the core STL library for now. And let's create a namespace. Okay, well, before we do that, let's include, or let's create a, or we'll forward declare our Moongate namespace, and then we'll just call our first object engine. Just because everything requires an engine all the time, right? That's usually the first class that just about everyone creates. Okay, so in the include folder, we're going to create a, oops, hit the wrong thing. Okay, we're going to add a new item. We'll call it engine.h, and just make sure that it's going into the include folder here. Ta-da! Okay. If in def engine.h, engine.h, and we're going to include our moongate.h. Actually, we won't need to. I'll put a namespace moongate and class engine. Let's see. I'll just give ourselves a basic constructor and a virtual default destructor. Okay. And okay, then we'll close it up with an end if at the bottom. All right, and then for our source files, we'll just add a moongate.cpp, and we will put that in the project folder /source. Let's call it engine.cpp. All right. Okay, we'll include engine.h, and we will also include moongate.h. Okay, so namespace moongate, engine, and then we're just going to, just for now, we're just going to IO stream. We're going to see out, oops, see out engine. Okay, and then standard end of line. All right. So basically, when we create an instance of engine, we're just going to spit out engine. Okay, and let's see. Engine. Okay. So it can't find moongate.h. You'll notice the red you'll notice the red highlighting of the include paths. So what we need to do in our static lib project is open up properties, and we're going to set the include directory to a special macro. We're going to use project dir. So just type in project dir correctly, and the include folder. Okay, so that should apply to all release. Oops. Shoot. I meant to specify all releases, all platforms. So let's take it out of here and hit apply, and then make sure that this is set to all configurations, all platforms. And we want to set, okay, project dir, oops, project dir /include. Okay. Coolio. Okay, so now if we build, it'll say cannot include SDL.h, or it cannot find SDL.h. So now what we need to do is almost the same thing. We need to, for all configurations, all platforms, we need to go into our external, it won't matter, external include directories or include directories. I kind of prefer sticking them in the external include directories just because we're needing to go outside of the project to reference where I've got SDL2 installed. So you'll have to do the same thing on your machine wherever you've got SDL2 installed on yours. And let's get this show on the road. Okay, SDL2 2.0.20, the include folder there. Okay. Hit OK, hit apply. And library directories, I suspect we're going to need to. Okay, so for now we've got a Moongate engine. Well, we've got everything building. So it's going to be created in the, I'll just show you where everything is built. So on the parent directory level, there's a new folder called debug, which now has our Moongate staticlib.lib file, library file. So now let's create a new game project. Let's create a new game project which will make use of Moongate. So let's go, if we highlight the solution, right click the solution, and we add new project, and we want to add a Windows Desktop Wizard is fine. It could also be an empty project. That's in effect what we're going to be making. So let's just call it, I'm just going to call it Snake. Let's start with a Snake project. Okay, and it's going to be a desktop application exe, but it's going to be an empty application. Make sure we're not inheriting the configuration from anything. And hit OK. And you can see now that we've got our Moongate static lib and our Snake project. So let's make our Snake project as our startup project, so that this means if we use our debugger options up here, it will try to run or debug our actual game instead of running something from the library. Okay, so again, let's right click on Snake there, open folder in Windows Explorer, and let's just go ahead and create a source folder. Okay, and then within that source folder, we can create a main.cpp. All right, main.cpp. Okay, and then under the Snake project, under source files, let's add to an existing item. We want to pull in this main.cpp, and then what we're going to do is we are going to include moongate.h, and we're going to include IOStream, although technically we don't need it because I think that's, is that already in moongate.h? Nope. Okay, so I just have SDL in there. Okay, and then we're just going to set up our main function, so int main int argc char star argv, and we are going to create a instance, so Moongate engine equals new Moongate engine, and then return 0. So we would expect that when our program runs and it instantiates an instance of Moongate engine, then it will go ahead and display engine in the output. Okay, so right now it doesn't know where anything is. You can see the red underscores and highlighting here. It doesn't know where our moongate.h project is. So let's go ahead and update kind of the same directory structure that we did last time. So for include directories, let's go ahead and hit edit, and then we want to hit the new one, or the new icon, hit the macros, and we want to try this time solution dir. So we want to reference the solution dir slash moongate static lib slash include. Okay, and that will let us find, Okay, so now with the underscore, the error checking is fine with that new definition. Okay, and now we also don't know what to do with, or the editor now doesn't know what to do when we link it. So you'll see that when I build it, it'll say, okay, it'll still say that we cannot find SDL.h. So I think we can, I don't know if we have to set it in both. Let's try setting it first in our Moongate static lib. So let's highlight that Moongate static lib project. Oh, we've already got it set up. Okay, so now let's do the same thing for Snake. So that means we're gonna have to do it for everything. External include files again. Okay, open edit, and then we want to reference our path here for our STL220 include. Okay, and then we're also gonna have to set up where we want to pull in the library files. So let's just do that right now. So let's just start with Win32. And under library directories here, we are going to hit new again, and we're going to go into the, whoops, at least for me, I'm going where I installed SDL2 2.0.20, and we're going into the x86 folder because we're referencing the Win32, and then we also want to create a new entry here, hit the triple dots, and we want to use the okay, hang on, let's hit OK there, let's hit apply, and then let's go to debug. So under the configuration, let's highlight debug. We're still in Win32, and now for library directories, let's go to edit, hit a new thing, open the triple dots, and what we want to do, or macro, sorry, is solution dir /debug. Okay. And then under our linker, we want to include for everything, make sure all configurations are set for all platforms. We want to include SDL2.lib, SDL2 main.lib, and Moongate static lib.lib. Okay. So now if we build it, okay, use of undefined type. Okay, and then let's go down here and let's delete engine. Since we're creating an instance of it, okay. And oh, of course, I have to include, let's see if that works. Okay, so you'll notice here in the output for our building our static library, where we've updated the definition, we've added the definition for our include file to engine.h, which will, we've forward declared the class here. And so now what happens when we run Snake? It should probably give us an error, okay, and that is because we don't have the DLL for SDL2 in our folders either. Okay, so now we see that we've got the Snake executable binary, we've got the SDL2 DLL that we're expecting, and our Moongate static lib that we're statically linking to from the Snake project. Okay, so let's start again. Okay, that seemed to run. It exited right away, so let's make sure in our output here that we see our message. Maybe what would work better, since we need to work with engine anyway, why don't we go ahead and, okay, so let's do this right here. So let's try class Snake engine public Moongate engine, and then let's just We'll put this in a proper file in a few minutes here, but let's just make sure that this works. Snake engine defaults. Okay, for the destructor. Okay, so now what we want to do is we want to create a new instance of snake engine. Snake engine equals new snake engine. And then we want to pause, and then we want to delete the engine still. Okay, so then in the snake engine constructor, okay, and okay, so we're calling the superclass, which is Moongate engine. So we're calling the constructor for that, and once we instantiate the new snake engine, we should see console out. Okay, so press any key, and let's go looking in our debugger. And how come I just don't see it? And let's just try foo. Okay. Okay, there we go. We see foo showing up in our console log. So that's the way to make it show up. I guess it wasn't showing up properly just because of how Visual Studio handles the output IO stream, I guess. It's weird. I haven't really come across it that restrictive before. At any rate, whatever. So we're using a function called SDLlog, and we're just logging foo. Let's just call it, or let's just update that to be the engine constructor. And so then when we hit, let's go back into main, let's take out the system pause because we've just proven that it works. So let's again run it again. And then we see way down here, info foo. Cool, all right. So let's go ahead and let's actually look at creating a new window, a new project. Okay, so let's go back into engine. And then what we want to do is we will just do for the rest of this episode, we will just do a basic window. We'll just get that up and running. So let's add a protected keyword here, and let's add a SDL window pointer reference and a renderer. Okay. Up to you if you want to use underscores for your class members. Everyone seems to have a different convention when it comes to how they structure their C++ objects. So go ahead and update it and go wild. Do whatever it is that you want to do. Okay, so for public functions, let's do in startup and void update and then void shutdown. Cool, all right. And then so in our engine.cpp, okay, let's get that out of the way. So we're instantiating this, and let's do window equals null pointer and renderer equals null pointer, null PTR, however it is you want to say that. So into engine, let's create a body now for our startup function, and we want to do a int result equals 0, result equals SDL init, and let's just use the initialization flag of SDL init everything. Why not? And that'll return a negative value if anything goes wrong. So if result is less than 0, then let's use SDL log and just mention that we have a problem with SDL init. %s, and then we can use a function called SDL get error, which will pop off the last error on the SDL call stack. And let's return a -1. Okay, and now we want to window equals SDL create window. And let's go through our methods here. So first we have to give it a title. So let's just call it Moongate. We'll update on how to kind of customize your creation code, I think, next episode. So window pose, centered, and STL window pose centered. That will be our starting or our upper left XY coordinates of our main window. And then for width and height, we'll just use 1024 by 768. Again, we'll figure out a way to customize that later on so that you'll be able to pass in some parameters to this. And then we just want to STL window shown. We just want to show our window. Boom, done. Okay, so now we just check underscore window for null. And call our STL log function again. So STL create window, another %s, STL get error. Okay, and then a return -2 just to give us a different return value. And then let's do the creation method for our renderer. So let's do STL create renderer, and we want to give it the handle to our underscore window, -1 for the first available video device that it comes across. And then for flags, we just want to use STL renderer accelerated and STL renderer v or present vsync. Okay. And then we do the same thing. So if renderer equals null, then we log an error with STL create renderer %s and STL get error again. Okay, and then a return -3. Okay, so then what we want to do is, now that we're done all of our setup code, let's return 1 for sweet success. All right. So now we have an update. Or let's do the cleaning up code right now. So let's do void engine shutdown. Okay, and then let's STL destroy render, or yeah, destroy render underscore render, and then call STL underscore destroy window underscore window, and then STL quit. And then usually I like to just null out our render and window objects as they get cleaned up. Okay, now we go to our update function. And so what we want to do is we want to create an infinite loop that goes forever until we either quit it with by using the X on the main window to close the window, or if we hit escape. I think I want to add that capability in there. Okay, so bool quit equals false, and then we create a event variable. Okay, so and then in an infinite while loop, so while not quit, while STL whole event does not equal to 0. So while there's no events that are in the STL event queue, so we want to process all of them at once before we move on. So if our event type is STL quit, then quit equals true, and break from our while loop. Okay, and now if our event type is equal to STL key down, so we've hit some kind of key press on the keyboard, then we are going to go through and keysim.sim. Yes, I have to look that one up every single time I do anything with the keyboard. STLK escape, so every time we hit the escape key, we are going to also quit. So quit equals true, and break. Break from our while loop, our inner while loop. Okay, that goes there, that goes there. Okay, so now that we've done processing all of the events in the queue, in the STL event queue, what we're going to do is clear our renderer. Set render draw color to cornflower blue, renderer, and the color is 100, 149, 237 by 235. No, I don't memorize that. I also have to look that up every single time. And then we want to clear our screen, or clear our renderer, which in effect clears the background to that cornflower blue color. So we call render clear, and then we draw our game world, and then now we flip our render buffers to draw what's been put on the back buffer to the foreground buffer. Well, not really buffer, main buffer, graphics buffer. And then at the end of this, I usually put in a small delay to just let the operating system take care of anything else it needs to in between loops. Okay. So we've got update function, we've got a shutdown, and we've got a startup. And we'll know it's working because we are painting the background a cornflower blue during this main loop. Okay. So now back in our main. So let's so we've got a new instance of our snake engine. Okay, and then what we want to do is if result. Okay, so we can just do if engine startup is less than 0, then go to clean up and quit. Okay, otherwise we want to engine update, and then in our clean up and quit we'll drop down to here. We want to call engine shutdown, and then delete our engine instance. Okay, so let's go ahead and run this, and we should see a cornflower blue screen. Excellent. This is amazing progress. Okay, so, and we've got our Moongate title here, and it's a 1024 by 768, and it's nicely centered position on my desktop. And now if I hit the escape key, it goes away. It clears up. Awesome. All right. And so that will wrap up today's episode, I think. So we've got a basic static library in place that has our STL objects that I want to create in a shared way so that I can make use of them in other projects going forward. And we've got a test project here called Snake, which will eventually become a Snake game. So we'll keep adding on this library in future episodes, and yeah, stay tuned. If you like what you saw, give this video a like, subscribe to the channel, leave a comment down below and on what you wanted to see next. Do you want to see fonts? Do you want to see sprites? Do you want to see audio, using audio, the STL mixer? What's your kind of order of preference? And let's take it from there. All right. Have a good day, everyone. Peace.